we're going to apply this sometimes. For example, if you have 2 into bracket 3 to the power 2x plus 7 3 to the power x equals 15. We want to find x. We know that if you have a to the power m all to the power n is the same as a to the power m times n. So we can write this as 2 3 to the power x all squared, because this will be the same as x times 2 or 2x, plus 7 3 to the power x plus 7 3 to the power x minus 15 equals 0. Now, we have 3 to the power x, 3 to the power x. Let any variable, let's say y, be equal to 3 to the power x. So we can have 2y squared plus 7y minus 15 equals 0. Because this is 2, 3 to the power x is y, so 2y squared, that gives this one, plus 7, 3 to the power x is y. So in place of 3 to the power x, we can simply put y. Then we have 7y minus 15 being equal 0. We can solve this quadratic equation. Please check my other videos on how to solve quadratic equation by factorization or by the quadratic formula or by completing squares. If we decide to factorize, we have 2y minus 3, y plus 5, and this is equal to 0. So therefore, y will be 3 over 2, or y will be negative 5. Because when you multiply two numbers and you get 0, it means one of them is 0. So either 2y minus 3 is 0, or y plus 5 is 0. That gives this result. But we're not looking for y, we're looking for x. From here, y is the same as 3 to the power x. So we can say 3 to the power x equals 3 over 2. Or 3 to the power x equals negative 5. 3 to the power x can never be negative 5 because this is 3. 3 to the power no number will be a negative number. So this one has no solution. So we only solve for this. If 3 to the power x is 3 over 2, we can find log of both sides. If we take log of both sides, we have log of 3 to the power x being log of 3 over 2. If we apply this law, log of a to the power b is b log of a. So log of 3 to the power x is simply x log of 3. And that is equal to log of 3 over 2. We can divide both sides by log of 3. So x will be, when we divide both sides by log of 3, we have log of 3 over 2 divided by log of 3. And we can use calculators to find the answer. Okay, so we got log of 3 over 2 divided by log of 3. And that is 0.36907. Of course, we can round up to maybe 2 decimal places, just 2 decimal places for the final answer. Of course, we can check if our answer is correct. If we put this value in the original equation, the left-hand side and the right-hand side must be the same. Let's look at another example. If you have 5 to the power 2x minus 5 to the power 5x plus 6 equals 0, the same approach. This is the same as 5 to the power x all squared minus 5 to the power x plus 6 equals 0. We got 5 to the power x, 5 to the power x. We can let any variable, let's say y, be equal to 5 to the power x. So 5 to the power x here is the same as y. So 5 to the power x all squared is simply y squared. Minus 5 to the power x is y, plus 6 equals 0. We can solve this quadratic equation by factorization or by completing square or by the quadratic formula. If we decide to factorize, this will be y, this will be y. So we got y minus 3, y minus 2 equals 0. If you multiply two numbers and you get 0, it means one of them is 0. That means either y minus 3 is 0 or y minus 2 is 0. So we can have y to be 4 or y to be 2. But we're not looking for y. We're actually looking for x. And y is the same as 5 to the power x. So if y equals 4, that means 5 to the power x equals 4, because y is simply equal to 5 to the power x. Or if y equals 2, that means 5 to the power x equals 2. We can solve for x in each case by applying log to the both sides. If we apply log to both sides, we have log 5 to the power x equals log of 4. We consider this law. Log of a to the power b means b log of a. So this means x log of 5 equals log of 4. We can divide both sides by log of 5. So x becomes log of 4 divided by log of 5. We can find the answer. Anyway, we can use calculator here. Log of 4 divided by log of 5. That will give us 0.86135 and so on. But we can run off to maybe 2 decimal places. 0.86, the answer to 2 decimal places. Then we come to this side also. This is for when y is 4, but y could be 2. If y is 2, the same approach, we apply log to both sides equals log of 2. And it follows from the law, x log 5 equals log 2. We divide both sides by log 5. So we have log 2 over log 5. And we can find x. We can find x to be 0.43 to 2 decimal places. So that's very simple. Okay, so let's consider maybe 2 more examples, or maybe 1 more example. Okay, so if we have 4 to the power x plus 2 to the power x minus 12 equals 0. This is 4, this is 2, but of course, 4 is the same as 2 squared. X plus 2x minus 12 being equal to 0. This is the same as 2x all squared, because if you have a to the power m, n is the same as a to the power m or n, or a to the power n or m, because in each case m will multiply n to get mn. So whether 2 to the power 2 times x or 2 to the power x times 2, 2 will multiply 2 to get 2x is the same thing. Plus 2 to the power x minus 12 being equal to 0. Of course, we can let any variable, say y, be equal to 2 to the power x. And we can have y squared plus y minus 12 being equal to 0, because 2x is y, so this becomes y squared. Of course, we can solve this quadratic equation as before. We just use the same approach, whether by factorization or by the formula or by completing square, you get the same thing. If you solve it properly, you will get y to be 3 or y to be negative 4. But we're not looking for y, we're looking for x, because in the original equation, there is no y, it's x. And y is actually 2 to the power x. So 2 to the power x equals 3 because y equals 3. Or 2 to the power x equals negative 4. But we know that 2 to the power x cannot be negative 4 because no matter the value of x, 2 to the power no number will give you negative 4. So this has no solution. So 2 to the power x cannot be equal to negative 4. So we can solve this equation. The same approach, we apply logarithm to both sides. So we have log of 2 to the power x equals log of 3. And we have x log of 2 being equal log of 3. Of course, we can divide both sides by log of 2 to get log of 3 divided by log of 2. We can use calculator here. If you have the logarithm of 3 divided by the logarithm of 2, you get x to be 1.58 to 2 decimal places. Of course, it's 1.58496 and so on and so forth. All right, let's look at last example. If you have 9x equals 3x plus 1 plus 27. Of course, this is 9, this is 3 to the power x. So we can express this as 3 squared or x, because 3 squared is 9x. So this becomes 3 to the power 2x. If we have a to the power m plus n, but the loss of indices is a to the power m multiplied by a to the power n. If you do not understand indices, please check my video on indices. So this 3 to the power x plus 1 is the same as 3 to the power x multiplied by 3 to the power 1 plus 27. Of course, we can arrange this properly. This is 2. 3 to the power 2x can be 3 to the power x or 2, just like before, just like in the previous example. This can come across the equal to sign. It's positive, so it becomes negative. 3 to the power 1 is 3. We got 3 to the power x. Positive 27 can come over across the equal to sign to become negative 27, being equal to 0. If we let any variable, let's say y, being 3 to the power x, then we got 2. 3 to the power x is y, so we can say y squared minus 3y minus 27 being 0. And we can solve this equation by either factorization or by the formula, any approach of solving a quadratic equation. We can use the formula. If you use the formula, we will get negative 27. So that will give us y equals 9 over 2, or y equals negative 3. This means 3 to the power x cannot be negative 3. Therefore, 3 to the power x is 9 over 2. We apply the same approach. We get log of 9 over 2 over log of 3. So that gives us a simple answer. Log of 9 over 2 divided by log of 3. So that is 1.37. All right, see you again for the next video.